Hey everyone, welcome back for some more stoichiometry. This time, we're going to look at mass-to-mass conversions. So before we had seen how to convert between moles of a substance into moles of another substance using the mole ratio. In general, stoichiometry will go back to using this mole ratio, and essentially everything else comes from how to get to the moles and then how to use the moles we're given. So the mole ratio is really kind of the center of it all. So a helpful idea to kind of always think about when approaching stoichiometric conversions and these types of problems is thinking you got to find your moles, because you really can't do anything in terms of relating chemical quantities without moles and that mole ratio. And the mole ratio would only work for moles. So whenever we're given a problem, we always kind of want to start off thinking, how can we use this to get our moles? Now, either we'll be given moles or we'll have to calculate and find it, but getting your moles should always be the first step to a stoichiometric problem, and then the second step, using the mole ratio, and then finally, we can go ahead and use those moles into whatever the problem's asking us to find it. So let's take a look at some examples where we're no longer starting with moles, but we have to use and find them. So we're told here that N2O5 is heated and it's going to decompose into the following reaction. We're asked what mass of N2O5 was used if 210 grams of NO2 were produced. So in the previous questions, we were given one quantity and asked to find another. Here, you might be tempted to go straight from the 210 grams of NO2 and use our mole ratio from the balanced equation, knowing that it's a 2 to 4 ratio of NO2. And you would think that it's just 210 times 2 over 4, which would be 105 grams of N2O5. However, this is not the right way to go about it, because that ratio of 2 over 4 from the balanced equation comes from the coefficients, and the coefficients are not representative of mass. They are representative of moles. So we can't use that 2 to 4 ratio until we have moles, and that's why we should always kind of start off with thinking, what do we have, and how can I use this to find moles? So our first step is going to be to get our moles. And that's really what we want to do to start off stoichiometry problems, to kind of figure out how can we get moles from whatever we're given. So in this case, we're given a mass. And so we're going to take our mass of 210 grams of nitrogen dioxide, and we're going to convert that into moles. So just dividing by its molar mass. Its molar mass is 46.01. So 210 grams of nitrogen dioxide is really 4.6 moles of nitrogen dioxide. Now that we have our moles, now we're okay to use the mole ratio. That's essentially our second step, is to use the mole ratio. With this mole ratio, we can then convert from moles of one substance into moles of another. So in this case, we want to know how much N2O5 were used in order to produce these 4.6 moles of NO2. So now we're going to use our mole ratio. We're going to take 4.6 moles of NO2, multiply by this 2 to 4 ratio. So 2 N2O5, and that is going to equal to 2.3 moles of N2O5. Now that we have our moles of N2O5, we can then use this to answer the question, which was what mass was used. So that's our third step here, use your moles. So once we've got our moles, let's go ahead and convert to what the problem is asking for. In this case, it's asking for mass. So we're going to take our 2.3 moles of N2O5, convert it into mass by multiplying with the molar mass of 108.02 grams per mole. And that gives us a mass of 248 grams of N2O5. So in this question, although we were not given moles to begin with, and were asked about a mass of one quantity when given another mass, it really came down to we had to just find moles, convert with the mole ratio, and then use the moles to find whatever it is that we're looking for. And stoichiometry problems can really kind of be broken down into these 3 steps. It's finding moles, and that's going to vary. In this case, we were dealing with mass, so we'd have to use molar mass, but we're not always going to be limited to just that. Then it's mole ratio, and then it's using our moles for whatever it is the question's asking for. Let's take a look at one more example. So here we want to know if 6.5 grams of aluminum reacts with an excess amount of oxygen, how many grams of aluminum oxide are formed? So to start any kind of stoichiometry problem, the first thing that we need is a balanced chemical equation. So in this case, we're not provided one, and we have to go ahead and write one. So we're told that aluminum is reacting with oxygen, and it's producing aluminum oxide. Once we have our reactants and products written, now it's time to balance, because we will need these coefficients later on. Now we've got our balanced equation, and now we can start and go ahead and go through our process. Here we want to know how many grams of aluminum oxide are going to be made. So we're looking for a mass of aluminum oxide. We're told that we're given 6.5 grams of aluminum to begin with. So we are looking at, again, a mass-to-mass problem. So it does not change our approach. Stoichiometry, first step, get your moles. So we got to take our 6.5 grams and convert it into moles. That's exactly what we're going to do here. This time, though, I'm not going to be breaking this up. I'm going to be actually just kind of chaining all of our steps together, so we can just kind of see how we can add the steps together into one essentially long conversion. So we'll be starting off with, 6.5 grams of aluminum. And we're going to convert that into moles, dividing by the molar mass of aluminum. So this step right here is what's going to help us find our moles of aluminum. Once we have our moles of aluminum, we need to convert that into aluminum oxide. So our second step is going to be to turn our moles of aluminum into moles of aluminum oxide by essentially using the mole ratio. So we're going to take our moles, and that's what the first step is going to give us, and we're going to multiply it by the mole ratio. So our mole ratio here is a 2-to-4 ratio. 2 aluminum oxides for every 4 aluminum. And this step will get us moles of aluminum oxide. Once that step is done, we'll have moles of aluminum oxide. And now the last step is going to be to go ahead and convert it into a mass. So once we have moles, we just have to multiply by the molar mass of aluminum oxide, which is 101.98 grams per mole. And this third step will get us to grams of aluminum oxide. We just go ahead and calculate it all. So we end up getting 6.5 grams times 1 over 26.98 times 2 over 4 times 101.98. And we get 12.3 grams of aluminum oxide can be formed. Okay, so it really comes down to, again, those 3 steps. Get your moles, use the mole ratio, and then use your moles afterwards. What you begin and what you finish with will kind of depend on the problem, but this is essentially what stoichiometry is all about and how these problems can be handled. So if we just want to write out a small little map to give us an idea of the steps to follow for stoichiometry, right now what we've seen is that we start with the mass of substance A. We convert our mass of A into moles of A by using molar mass. Once we have moles of A, we can convert that into moles of B by using the mole ratio of B over A. This is going to come straight from the balanced equation. Then once we have our moles of B, we're able to convert that into mass of substance B. Now, problems are not always going to ask us to go directly from mass to mass. They can be from moles to mass to moles, right? We don't have to go the full 3 steps. We can stop at 1, 2, or as many as 3. It will really kind of depend on the scenario that we're given. But this is essentially the steps that we go with. We take the mass of A, convert it to moles, use the mole ratio, and then we can convert the moles into mass. Okay. Ugh.